Do you want us to do it step by step?
So, okay. You actually need about 3 points and the origin to determine what the graph looks like. So because it's base 3, you know that if you put in 1 in here, it becomes 1. 3, right? So we know that 3, 1 is 1 point. If you put 1, it's always 0. And if you plug in -1, it's 1 over 3. Agreed? This is for log of x base 3. So let's say this is our function, f at x. Then this thing can be written as minus 2 times f at x plus 1, right? That means it's got a horizontal shift of -1 and a vertical stretch of -2, which means there's a reflection on the x-axis. So we can also write this. The original points from f at x will transform in the following way: x minus 1 and minus 2y. So what that means is that this point right here will move to 2 and minus 2. This point will move to 0 and 0. And this point will move to minus 2 and minus 2 over 3. It's also useful to move the origin. Okay, it's not on the graph, but it's a very good reference point. So it's -1 and 0. Okay, so we have -1, so this is the y-axis, and this is the x-axis. -1, and 0 is a reference point. So that's going to be our new asymptote, new vertical asymptote, okay, -1. Let's plot the other points. 1, 0 becomes 0, 0. Becomes 2, -2. 1, 2, -2. Okay, and at -2 becomes -2 over 3. So there's an error here. This actually should be a 1 over 3 -1. So I did it backwards. So if you subtract 1 from that, you get a -2 over 3, and you get a +2. Okay. So -2 over 3 will be here, about here. Okay, and +2 would be 1, 2 right here. Okay, so it's these 3 points. 1, 2, 3 with the asymptote. So can you imagine what the picture would look like? So it approaches this line, passes that point, and it'll grow this way.